All right, welcome back to another video. In the last video, we finished learning about BGP communities. Just kind of to summarize, BGP communities are extra tags or strings you can add onto a BGP route. It's an optional transitive BGP path attribute, so it does not have to be supported by all devices, but it is sent out to other devices. So there's well-known attributes, there's optional attributes, there's well-known mandatory attributes. So these are attributes that have to be included on every implementation of BGP on a device. They have to support it if it's a well-known attribute. Mandatory means it's, well, I'm kind of stumbling here. So I'm going to pull up a tool I made to help learn about this. It's right here, path attributes, and kind of summarize that. So I was right that we have mandatory, we have well-known, we have optional, and that we have well-known, mandatory, and discretionary, and optional, transitive, and non-transitive. But I am not, I think, correct about what it means for something to be well-known, mandatory. So for something to be well-known, all routers must recognize the path attribute. You can't have a device that does not recognize well-known BGP path attributes. For optional, the BGP implementation on the device doesn't have to recognize that path attribute at all. If it's well-known mandatory, the update must contain that attribute. If the update does not exist, a notification error message will result and the peering will be torn down. So we know that communities are optional transitive. We can see them right there, community, extended communities. I'm pretty sure large communities are there as well. This isn't all encompassing, but those are optional. The device doesn't even have to support them, but they are transitive. The device needs to pass that path attribute on towards its next neighbor. So well-known discretionary, the attribute does not have to be included in an update. And we saw in the last video, we did that with the local preference. We changed that well-known discretionary using it. But local preference does have to be recognized by the BGP implementation on the router, but it does not have to be included in an update message. So mandatory discretionary are kind of similar to transitive and non-transitive. Because transitive, the device needs to pass that path attribute on towards its neighbor. Mandatory, the update must contain that attribute. So it's the same thing, an update message. If the update does not, but it's a little bit, yeah. So they're kind of the same thing. And then discretionary, the attribute does not have to be in the update. Non-transitive, it can just ignore the attribute value. So that's kind of a summary of the last topic. We also kind of went above and beyond and learned about how to set up a management server using SSH RSA public keys. So the next topic that we're going to start right now is understanding how IPv6 can be tunneled over IPv4. So the name of the topic is IPv6 tunneling for BGP. So I did have this bookmarked here, understanding redistribution of IPv4 routes with IPv6 next hop into BGP. But it looks like this whole thing is going to be really valuable, configuring IPv6 routes over IPv4 transport. This whole page is going to be really valuable. So I think I'm going to do this whole page, but I'm going to stop it configuring BGP to redistribute with IPv6 next hop addresses. So yeah, I'll do all the way through here, but I'll stop it at the layer 2 VPN stuff because I had already finished all that. Unfortunately, I didn't finish it on video, and there's a lot of spanning tree stuff in there. So maybe if there's extra time in the exam, I can, before I take the exam, I can go back and and make a video on that. But for now, let's start the IPv6 tunneling portion of the BGP section of the exam. Understanding multi-protocol BGP. Multi-protocol BGP, MP BGP, is an extension to BGP that enables BGP to carry routing information for multiple network layers and address families. MP BGP can carry the unicast routes used for multicast routing separately from the routes used for unicast IP forwarding. To enable MP BGP, you configure BGP to carry network layer reachability information, NLRI, for address families other than IPv4 by including the family INET statement. So this is what I had thought it was actually, because I remember, well, in a previous video, I had talked about, oh, what's the difference between standard BGP and multi-protocol BGP? But as you can see here, it's just a matter of including different kinds of protocols into BGP. So to enable MP BGP, you configure BGP to carry network layer reachability information for address families other than IPv4 by including the family INET address. So you gotta include family INET, and then in there you can do some extra options. To enable MP BGP to carry NLRI for IPv6 address family, include the IPv6, include the family INET 6 statement. On routers only, to enable MP BGP to carry L3 virtual private, so we can skip this because that was its own topic on the exam. I went through that. Unfortunately, I don't have it on video, but I did complete that, and time is definitely ticking very, very fast before this exam. It's already almost May. And I'll be doing a math. Once I finish this module here on BGP implementation, I'll be doing some math to try to see if I'm on target or not. And I have a feeling I'm very, very far behind. Okay, so that's still about VPNs. Yeah, okay. So by default, BGP peers carry only unicast routes used for unicast forwarding purposes. To configure BGP peers to carry only multicast routes, specify the multicast option. To configure BGP peers to carry both unicast and multicast routes, specify the any option. When MP BGP is configured, BGP installs the MP BGP routes into different routing tables. Each routing table is identified by the protocol family or address family indicator, AFI, and a subsequent address family identifier, SAFI. The following list shows all possible AFI and SAFI combinations. Oh, okay. So this is kind of how it knows that what the protocol is in multi-protocol BGP. So this is the one we're going to be concerned about for BGP tunneling, possibly multicast as well. So it's 2 and 1 or 2 and 2. I think, unless there's one for tunneling specifically. No, that's it. Routes installed in the INET.2 routing table can only be exported to MP BGP peers because they use the SAFI, identifying them as routes to multicast sources. Routes installed in the INET.0 routing table can only be exported to standard BGP peers. The INET.2 routing table should be a subset of the routes that you can have in INET.0, since it is unlikely that you would have a route to a multicast source to which you could not send unicast traffic. The INET.2 routing table stores the unicast routes that are used for multicast reverse pass forwarding checks and the additional reachability information learned by MP BGP from the NLRI multicast updates. An inet.2 routing table is automatically created when you configure MP BGP by setting NLRI to any. Okay, that's interesting that it says that you create MP BGP by setting NLRI to any, but then up here it says that you enable it by saying family INET. It seems like there's contradictory information that actually might be worth a download. I mean, I frankly have found it kind of difficult to learn about MP-BGP specifically and how it's different from regular BGP. So if there's going to be misleading or unclear information out there, I'd like to kind of identify it as such. So let's put these two statements together and see if side by side they make more or less sense. So the first statement is, to configure MP BGP, you configure BGP to carry network layer reachability information, NLRI, for address families, and I'll add a new line, other than unicast IPv4 by including the family INET statement. So to enable MP BGP, you configure BGP to carry, and then here it says, an inet.2 routing table is automatically created when you configure MP BGP by setting NLRI to any. So yeah, I don't know what any of that means, but hopefully it'll be more clear by the end of this topic, because if we're doing IPv6 for BGP, that definitely is MP BGP because we've got multiple protocols. All right, so limiting the number of prefixes received on a BGP session. You can limit the number of prefixes received on a BGP peer session and log rate limited messages when the number of injected prefixes exceeds a set limit. You can also tear down the peering when the number of prefixes exceeds the limit. Okay. If you include the teardown statement, the session is torn down when the maximum number of prefixes is exceeded. If you specify a percentage, messages are logged when the number of prefixes exceeds the percentage of the specified maximum limit. After the session is torn down, it is reestablished in a short time unless you include the idle timeout statement. If you include the idle timeout statement, the session can be kept down for a specified amount of time or forever. If you specify forever, the session is reestablished only after you issue a clear BGP neighbor command. So this might be on the test. I might want to make sure I'm not receiving too many. I mean, I doubt it though, because that'd be kind of hard. I'm sure it's going to be more troubleshooting those import or export policies. Limiting the number of prefixes accepted on a BGP peer session. You can limit the number of prefixes that can be accepted on a BGP peer session. When that specified limit is exceeded, a system log message is sent. You can also specify to reset the BGP session if the limit to the number of specified prefixes is exceeded. To configure a limit to the number of prefixes that can be accepted on a BGP peer session, include the accepted prefix limit statement. Okay. Oh, this is the same thing that was up there. Okay, well, I don't want to keep reading things if they're not going to be valuable, because I need to really get moving. So this rib group looks like it might be important to know about. When a BGP session receives a unicast or multicast NLRI, it installs the route into the appropriate table, INET 0 or INET 6.0 for unicast, and INET.2 or INET 6.2 for multicast. Okay, so you can see already we were very strongly misled by what that INET2 was. It looked like it was an INET2 routing table is automatically created for you when you configure MP BGP. So, you know, it looked like it was related to all BGP, MP BGP traffic, but INET.2 is just for multicast. To add unicast prefixes to both the unicast and multicast tables, you can configure BGP routing table groups. This is useful if you cannot perform multicast NLRI negotiation. To configure BGP routing table groups, include the RIB group statement. Okay, we're almost at the example. You can allow labeled routes to be placed. Okay, so this is label routes. This is for VPN. I'm going to read this one time though, because I remember this was kind of an important knob to know about. Resolving routes to PE routing devices located in other ASs. You can allow labeled routes to be placed in the INET.3 routing table for route resolution. These routes are then resolved for provider edge routing device connections where the remote PE is located across another autonomous system. For a PE routing device to install a route in the VPN routing and forwarding VRF routing instance, the next hop must resolve to a route stored within the INET.3 table. To resolve routes into the INET.3 table, include the resolve-VPN statements. So, yeah, and INET.3, that's for like VPN. Yeah, it says it here right here. It's for a PE routing device to install a route in the VPN routing and forwarding routing instance. The next hop must resolve for a route stored within an INET.3 table. So INET.3 is more for VRF instances. All right, but let's continue. So this example demonstrates how to export both IPv6 and IPv4 prefixes over an IPv4 connections where both sides are configured with an IPv4 interface. Keep the following in mind when exporting IPv6 BGP prefixes. IPv6 derives next hop prefixes using the IPv4-MAC IPv6 prefix. For example, the IPv4 next hop prefix 10.19.1.1 translates to the IPv6 next hop prefix : :FFFF:10.19.1.1. And that's interesting because we know that EUI-64 I believe has FFFE. Yeah. I was about to say, like, did I just completely fail about learning EUI-64 and it was FFFF the whole time and I just learned wrong that it's FFFE? It's like, no, I learned EUI-64. I know it really well. It's FFFE for sure. And then you flip the 7th bit and then you use the MAC address so you split the MAC address in half. And for the 08 UI, you flip the 7th bit, then you use the FFFE, and then you use the second half of the MAC address. So this is not an EUI address. It looks like it's just a specially mapped address for IPv6 where it's all Fs and then the IP. Note, there must be an active route to the IPv4 mapped IPv6 next hop to export IPv6 BGP prefixes. An IPv6 connection must be configured over the link. The connection must be either an IPv6 tunnel or a dual stack configuration. Dual stacking is used in this example. When configuring IPv4 mapped IPv6 prefixes, use a mask that is longer than 96 bits. Configure a static route if you want to use normal IPv6 prefixes. This example uses static routes. All right, so I've got this already ready to go in the lab. So all I need to do is go in and configure it. I'm going to use out-of-band configuration because they're all in their own AS, so it wouldn't really be realistic for me to use one server for all three of the devices. So let's start with router R1. And luckily the ports were ending in 0, 0, 1, 0, so it makes the port naming really easy. Oops, and it looks like I've got some extra ones open. Let's just close those. All right. Oh, and you can see they haven't overcome their addiction to unit numbers that are not valid. They seem to be very fond of using invalid numbers for their units. That has shown up in many documents. And that is, as I've explained many times before and submitted many downloads for, I can't, of course, submit it down for every single time I see it. I can, but you know, at some point I want to study for the exam, so just submitting downloads all day. It is unfortunate when you're trying to learn something and they tell you to do something counterproductive to your learning. All right. Yeah, as I said before, it's kind of frustrating sometimes where you're trying to learn a concept and the only way to learn the concept is to have already learned the concept. Like if you didn't know it, you're not going to know enough to be able to overcome the misinformation or materials you've got. And that's where some kind of coach or mentor is really important, because I really think that is true. Sometimes in order to learn a concept, you have to have already learned the concept. So the next best thing you can do is talk to somebody who has already learned the concept, and that's really all you can do. All right, so it looks like we're references. So we're trying to call in something called send static. Oh, okay. So I bet you I accidentally used. Let's see what we got under here. So show policy options. Display set. So I've got a policy named send. Oh, I'll do the relative, my favorite keyword. So I've got the yep. So you can see both terms here are added under the one. So I forgot to change the name of the policy statement, and instead I just configured a single send direct statement with the configuration from some send static included in it. So I'm going to need to clean that up. But I did correctly call the configuration. I just didn't correctly define it. All right, but second chances are always a possibility, especially in Juniper where you've got that candidate config really nice. And from what I understand, kind of an interesting thing to know is the candidate config from Juniper is modeled after, or it's vice versa. But if you look at the RFC for netconf, it has a candidate config mechanism that's very similar to the candidate config feature of Juniper's. So from the same flock, and they're really useful. Birds of a feather. Okay, so hopefully this is good to go now. It looks like it is. Commit and quit. I've got the, well, I can do a final show configuration. And oops, yeah, it looks like it's, nope, it does have the autonomous system. Okay. So they're using their classic invalid unit numbers again, but I know to use unit 0 unless I want to enable VLAN tagging. Oops, and it looks like there's an error up here. Fix that quick. There we go. Good thing I caught that before it committed. Oops, so it looks like we got a problem here. Must define local autonomous systems. So I thought I did that. Oh, my command didn't take, it looks like. So yeah, because I did the edit and not set. So set, oops, set, come on. Set routing options, autonomous system. Perfect. All right, 2 more commands left, and then we'll have verification. Looks like it's randomly switched tabs again, which again is something that if you know how that happened, leave a like in the comments or leave a comments, because to have the ability to switch tabs like that is something like I really, really desire. So for it to just happen accidentally occasionally is really frustrating to me, because I would like it to happen intentionally, like, because that's going to be kind of a game changer when I figure out how I can have that happen, not by accident. So I really would like to know that, if anyone can help me out, how it actually is changing tabs by accident, but regardless of whatever key combination I enter in intentionally, I am unable to change tabs. All right, so we've got 2 more commands. All right, well, let's go through the step-by-step and see if there's anything interesting. So enable BGP to carry IPv4 unicast and IPv6 unicast routes. So here's where we're including those family statements to make it MP BGP. This is something we didn't have in our other configuration we were looking at earlier. And it looks like that's because it's enabled by default. So we need it because we're going to enable it for IPv6. All right, so it's time for verification. All right, so the first thing we're going to do on router 2 is show BGP neighbor. Perfect, so everything looks like it's good, it's been established. Let's take a look at the address families configured. Okay, so we've got INET6. Let's take a look at the NLRI for restart configured on peer. Here we go, INET6. INET6. Oops. Looks like that's, here it says it's NLRI of received end of rib markers, but this is NLRI advertised by peers, so that's a little bit different there, but of course it depends on, oh, I'm sorry, I thought I figured out what the key combination was to switch tabs. I thought it was like, I'm pretty sure it's like a alpha, like maybe it's like space T or like space control T. That's kind of why I had that reaction, because I really want to know what that combination is. So it's going to be very exciting when I figure that out. I've been able to switch tabs accidentally multiple times, so it's clear that there is some sort of key combination I am pressing that allows it to happen. Okay. Let's take a look at the IPv6 table. All right, so everything looks good. Yeah, so let's just move on to the next one. Let's do a quick Wireshark before moving on. And maybe do some changes in the config. So let's wipe out the config here. It's just the whole thing. Let's see what happens. Oh, cannot commit an empty configuration. That's nice. I'm glad about that. Okay, so we're going to get some update messages clearly. Aha, there it is. So we're going to see some withdrawn routes. There we go. I'm surprised it's just the one. I'm surprised we're not seeing more withdrawn routes. But let's maybe take a look. Well, let's revert that configuration and then take a look at what it was we actually did. So we're going to get another update, of course. Here it is. And yep, now we've got it back. So we've got our well-known mandatory attributes right here. Yep, and that's for this route here. I'm kind of surprised that we didn't see anything for IPv6. Kind of surprised that that wasn't included in the message. Let's take a look at this command again and make sure that it matches. Yeah, it looks like it does. Yeah, I'm actually really surprised that there's no, well, maybe because I'm sniffing the wrong link. Yeah, I'm going to try wiping this configuration. All right, so now let's find our update message. Maybe it's even got IPv6 in it. Aha, so here we got a notification message because of course we didn't receive those path attributes. Well, actually I bet you it's because it didn't respond to the keep alive. But let's look at what it says. So cease, yeah, it just ceased. So I'm going to commit this and hopefully we'll get our update messages. Yep, there's the three-way handshake again. So yeah, here's our update messages. So hopefully we'll see some IPv6 in there now. I'm not sure why it wasn't in the other one. Yeah, here we go. So IPv6 messages, very nice. I'd like to see the actual routes received as well, the IPv6 routes, to see if there's any difference in. Yeah, it looks like there is kind of a big difference between IPv4 and IPv6. And IPv4, you get the route showing up, but here in IPv6, I really don't see the route anywhere. I see the path at, oh, but this is unreach NLRI. We need reach NLRI. So this is one for a withdrawn routes. So we need one for not routes that are withdrawn, but routes that. Okay, so here we got a next hop. And here we got a route. Okay, so I think that's enough to end the video on. We learned about IPv6 tunneling over IPv4 connections. Oh shoot, there's like a spider that came down from the wall. Well, shoot. Yeah. So okay, so we learned about IPv6 over IPv4 connections. Let's see here. So let me see, configuring. Yeah, over IPv4 transit. And we can see that's the case because if I do a show BGP summary, you can see I've got well, I've actually got like 7 more. Yeah, so here we go. I've got one neighbor, and my neighborship is through IPv4. So very clearly, we're advertising IPv6 routes over an IPv4 BGP neighborship. And we're doing that because we have INET 6 unicast enabled as a family for our eBGP connection. All right, so Yep, and you can see on our peer address, which is an IPv4 address, we have an established connection for inet.6 protocol family. So you establish it for the protocol, and of course you can establish one via IPv6. That'll be the next example, but whether you establish it through IPv4 or IPv6 does not restrict or determine in any way the kinds of protocols you can advertise over it, because it's just carried on TCP connection, and then you just exchange routing information that way. So the actual contents of that message, it doesn't matter whether it's IPv6 or IPv4, as long as you tell BGP that you're going to carry that kind of information, which you do with those family commands here under the BGP group. So I hope if somebody's watching this, they got a lot out of it. I'll leave any questions in the comments, and thanks for watching.